let's get started. So I know you guys already sort of gotten a preview of what lists are in, I believe, day 2 of the class. But just in case some of you forgotten, let's just go over it. So there are 3 main terminologies you guys should know. So first of all, what is a list? Well, a list is basically a mutable data structure that holds any kind of data. Now, I highlighted mutable here because it's crucial to note um, that lists can essentially change throughout the program, meaning that you can either add, remove, or modify the data within the list. And this is the main feature and the powerful feature that it essentially provides. And the next terminology we should note is elements. Now, elements refers to basically the data within the list. And the next terminology you guys should know is index, which basically means the position a specific element lies within the list. Now, I came up with a brief analogy that sort of explains what lists does and basically their functionality. So, for example, let's just say a list is like my Pokemons, right? I can have many Pokemons and I can also arrange them in a specific way. Elements would be each Pokemon's, right? Because they belong within my team. And I'm able to modify my team based on what I need. For example, I could put the powerful ones at the beginning or the powerful ones at the last. And this sort of allows me to basically have the freedom to change my teammates, basically the Pokemons within my team, anytime in my journey. And that is what lists are essentially as well, right? You can modify data anytime throughout the program. And yeah, and also it's crucial to note that the first element within every single list always has an index of 0. And I know that kind of seems counterintuitive since like you would probably refer to the first thing in anything to be the number 1. But in this case, in the programming world, most programming languages assigns the index value of 0 for the first thing in a list. So that's sort of something you should keep in mind. And yeah. So how do you declare on, right? Now, you can have 2 approaches to this. The first approach is that you may not know what values you want to put in your list, so you can just make an empty list, as shown over here, right? The convention used for a list is just having a square bracket, and you always want to make sure you close it after you open it. So yeah, this is a valid way to declare a list. And another valid way is if you already have some sort of data values in mind and you just want to input them in the start of the, I guess, declaration, this is another valid way that you can make it. So for example, let's go to my Replit and make a list. So I can make a list of virtually anything, right? It doesn't just have to be of one single data type. For example, I could do a list of numbers, and that is totally fine, right? Let me just output the list. Right, so I could have just integers, right? I could also mix in floats. I could also mix in strings or booleans, and every single value of these is a valid way, is a valid entry essentially to making any type of list. So you can see that all of these values has been printed and there are no errors shown when running the program. So yeah. So one way to basically access one single element in a list is basically using this sort of format. And as you can see here, basically I declared a list with pre-existing entries. And if I wanted to access, for example, the last entry, I would use -1. And that would, again, output true. So remember that if you have an index value, here, let me go back to my example. For example, let's just say I wanted to print the first element within this list. I could do list 0, and this would run output the first element in the list. But if I wanted to output the last value, I would do -1. And it sort of makes sense if you sort of imagine this sort of like it was duplicating, essentially. For example, this is, let's just say we're using this list as the primary example. This element has an index value of 0. But if we go -1, the last element within the list would be -1. So that's kind of like a way you can visualize it if -1 doesn't really make sense at the beginning. And yeah. So now I probably already showed you one way you can iterate through a list, but this is another way you can also iterate through a list and print every single element within the list. So here you can see that we declared a list with the strings ABC, and we're basically going to iterate through the indexes of the length of the list. For example, we can see here that this has a length of 3, correct? So this range function would return a list of 0, 1, 2. And 0, 1, 2 corresponds to each of these elements. Therefore, you can see here in the output area, it will print out ABC. So yeah, let's try that on our example. So again, you can make a variable called anything, and you're just going to say for I in range the length of the list, print every element within that list. And you can see here that all the elements within this list are outputted. Now, the method that I showed you previously, this method, you can see here that again we have a list as well, and we're basically going to say for I in my list, and this basically means for every element within this list provided, you can just directly print that element. And this is sort of a shorthand notation you can use instead of actually iterating through the indexes. Basically, you can also iterate through the elements directly, and this is sort of like a shorthand notation you can use. So for example, back to our code, instead of doing this, we could also do let me just create some bars. We can also do for elements in the list, print elements. And again, this is just a much faster notation. I mean, not that fast, but it's another way you can basically iterate through a list. And you can see here that the outputs are the same. So yeah. Now here's a bit about list slicing. Now list slicing basically gives you the functionality to choose a particular set of elements, right? We went over previously how you can select one single element, right? We also went over how you can output all the elements. But what if you just wanted to output a specific section of the list? For example, what if you wanted the elements past the first element, right? What if you wanted every other element? What if you just wanted the last two elements, right? This concept called list slicing basically allows you to do that. So let's go over this code. So you can see here that we already have a pre-existing list called my list, and then we're just gonna print every other element. Now, if last class we went over basically the step argument, but if you weren't here for last class, I'll just go over that quickly again. So basically the step argument, basically the third argument, basically allows us to iterate through all of the elements, but only here, let me just like explain it here. So for example, let me just use this print list. Okay, so you can see here that if the step argument is 1, and by default it is 1, you can see here that it will output every single element. However, when the step argument is 2, it will skip basically every other element. So you can see here that it starts with the first one, but then now it adds 2 to the index basically. So for example, this starting index is 0, correct? But then now we're just going to add 2 to that. And now the index will be 2. So 0, 1, 2. Now it will print 3. And that is basically what the step argument does. It essentially allows you to define a value for the stepping functionality. So for example, if we wanted every third element, we can just specify that we want a step argument of 3, and then it will indeed print every third argument. I mean, third element, excuse me. And that is basically what this third option basically allows us to do. Now, if we wanted to basically cut and output a certain part of the list, we can basically use this format to allow us to state the beginning element that we want to start at and the last argument that we want to stop last element that we want to stop at. But it's important to note that the last element isn't, I mean, this basically the element with this index 3 over here isn't actually included. So for example, let's look at this example. So this basically says, give me the second and third element, right? But so this begins at 1, and we know that this has an index of 1, so this will be outputted over here. And we want to output the third element, which is this one. And again, it's outputted here. But the element with an index of 3 isn't actually outputted. Since this has an index element of 3, since 0, 1, 2, 3. But you can see here that despite this stating 3, it's actually not outputted in this basically like output channel. And that's kind of another thing you guys should note, that this second option isn't really included, right? So basically, if you wanted to include the last element over here, you can basically use this type, you can basically use this option, this code, which will say, okay, if you don't specify a second option, it will basically default to the end of the list. So now you're saying, okay, give me the elements starting at the index value of 1, and then give me the elements past that. So you can see here that this has an index value of 1, and then it's going to output everything past that. So you can see that in the code. It does exactly what I just said. So let's have a progress check to see that if you guys understand what these concepts. So basically, write a function called list splitter that takes in a list and returns the second half of the list. If there is an even amount of elements, split at length of the list divided by 2. If there is an odd amount of elements, split at length of the list divided by 2. So for example, if you have a list input given this, I want you to basically return a list of the second half portion. But if you have a list with odd number of elements, I want you to give me a list with basically this the total length divided by 2. I believe this is float float division. So basically 3 divided by 2 would be 1.5, and then round that up. So it will be the last 2 elements basically. And this option is basically just integer division. Since it's even, it would just divide perfectly. So it would be 6 divided by 2, and 6 divided by 2, which is 3, and then just output the last 3 elements. So everyone pull up your replets and try to write out this code, and I'll go over the solution in about, I'll give everyone around 4 minutes to complete this. Also, guys, I just want to clarify something. This two division bar is basically integer division. And back to this example, 3 divided by 2, I mean 3 divided by 2 would be 1.5. But then we want to round that down to 1, which will basically give us this list essentially. So yeah. Okay, time's up. I'll go over the solution right now and hopefully you can follow along. So basically this is the code. So again, we're going to create a function called list splitter and we're just going to see that this conditional statement basically checks that if the length of the list is odd, since the length, since any number modulus 2 and when it outputs 1, that means that there's an odd number of the length. So if the length is basically odd, we want to output the integer division result of it. Otherwise, we want to just, since otherwise it is even, we just gonna divide that length by 2, and then we're just going to output the list like that. Yeah. Okay, now we talked about lists. Now we can also basically do 2D list. Now, this is basically a list embedded within a list. And that may seem hard to grasp at the moment, but hopefully I can better explain it later on. But basically, lists can be two-dimensional. Each value in a 2D list has a coordinate basically, a row, column. The number 4 in the diagram at the right has coordinate 1, 0. So you can see here that 4 in the image has a coordinate of 1, 0. So in order to access it, you would first call the row 1, and then you will call the column, which is 0. And again, it's crucial to note that indexes start at 0. So let's dive into an example. So here we have a 2D list. And again, like I said, it's essentially just multiple lists embedded within just one list. And basically, we are going to look at how many elements this single list has. And we can see here that this has 2 elements, right? Basically 2 lists as well. And now we're going to say, okay, how many elements are in within each list. And you can see here that A of 0 basically accesses the first element, otherwise known as the first list within the 2D list. And then it's going to check to see how many elements there are within this list. And this is going to output basically 3. And now if you wanted to get the item in row 0 and column 1, basically row 0 would refer to the first element within the list, basically this list, and then column 1 would refer to the element with the index value of 1. You can see here that it basically refers to 3, and indeed in our output channel it is 3. So yeah, so basically let's go to our example and make this a 2D list. So for example, if I wanted to have a 2D list of A, B, C in one list and another list with D, E, F. And let me just format this so that it's easier to understand. I think Python will allow me to do this, but basically this would be row 0 and this would be row 1. And let's see if we can print the, let's just say we want to print A. So then we would first say, okay, we want to access this first element within this bigger list, right? That's why we want to specify the row value of 0. Okay, let's do that. And next, we want to specify another value, which is the column value. And now we want to say, okay, within this list, this specific list, I want to access the very first element, and that is also 0 as well. And let's see if this works. So yeah, you can see here that the output is A essentially. So yeah, again, there's this format is basically used for 2D list. The first chunk basically states the row value, basically which element within this bigger list you want to access, and the second value basically refers to which specific element within the chosen list you want to access. So again, this is the row value and this is the column value, right? So these lists would be rows, and within each list, the specific values would be columns essentially. And yeah, that's basically what this image refers to. Hopefully that code formatted in this specific way can basically like show you how it resembles to this image. So yeah. So now what if we wanted to loop through the 2D list? For example, let's just say we have 2D list basically, and then we wanted to basically increment every element in the 2D list by 1. So for example, let me just demonstrate here. Let's see. Okay, yeah. So for example, if I wanted to basically add, for example, the letter B to every single element within this 2D list, I could do the following. Let me just make sure. Okay, so for elements, let's just do for lists, for L in list, for element in each list. I want the list, the specific element. Actually, let's see, specific element to be here. Let me just see if this works. I think it should. Actually, let's just print the element. Yeah, so you can see here that basically we're saying we're gonna have basically two for loops, one embedded within the other. And then this is basically going to iterate, first of all, this will iterate through each list within our, here, that's getting a little. This will iterate through each list within our bigger list, within our arrow list essentially. And then this second for loop will basically iterate through each element within chosen list, right? So for example, this line of code will basically iterate through each list, and this for loop will basically iterate through each element. And then we're going to say, okay, I want to append the letter B to every element. And then, after we print the element, we can see here that it does indeed change the element within the 2D list. So that's one way, that's basically the way you can loop through the 2D list. So here's some handy functions for lists that you should probably know. So I really recommend that you guys take note of this specific one, length of A. Basically, this outputs the length of how big your list essentially is. Basically, how many elements your list has. And minimum basically outputs the minimum value, max outputs the maximum value, and sum basically sums up the list essentially. So after that, let's go over another progress check. And yeah, everyone please pull up your replit again. And basically write a function called list average that takes in a 2D list in which each element is an integer and returns the average of all the numbers. So for example, let me just show you an example. Give me a second. Let me just give you an example input. So for example, let's just say you were given this 2D list, right? 1, 2, 3, 4, 5, 6. And I want you to basically take the average of the sum of these numbers. So basically, take the sum of this and divide it by how many elements there are in here. And that will basically allow you to calculate the average of the list. So yeah, everyone pull up your replit, and I'll give everyone 4 minutes to do this. And yeah. Okay, guys, on second thought, I'll give everyone 15 minutes to do this. Hopefully, that will get everyone enough time to do so. And yeah. Okay, guys, time's up. Hopefully that was enough time to give everyone some time to write their code, and hopefully it worked. But if not, then I will go over the solution and hopefully you guys can get a better understanding of how it works. So basically, in order to calculate the average of the 2D list, you will need to first of all find how what the total value is of all the elements added up together, as well as the total number of elements. And if you have those two values, you can divide them and that will output the average. So let's look at this code and see how it works. So basically, like I mentioned, you want to keep track of two main variables, the total value and the count value. And then, just like the previous slides before, we want to look at how many rows there are, basically how many lists there are within the outer list, as well as how many elements are within each inner list. And after we have those two values, we can now iterate through this 2D list and calculate the total by adding that specific element to the total, as well as increasing count. Since every time this code block runs, that means that there is an element that is being iterated. So then after we have those two variables, we can now return the division result from dividing total by count. And that is essentially how this problem works. And yeah, I hope that was helpful. And then, yeah, that was pretty much it for today's lecture. Thank you everyone for tuning in. We're having currently some technical difficulties with getting the homework problems posted on the Codeforces platform. But I do have the homework problems here right now. So if you guys want to take the remaining class time to look over these problems and hopefully come up with methods and ways that you're gonna write this code. And yeah, that's pretty much it. If you guys want to stay here to ask any questions, feel free. But other than that, I think everyone's free to go. Thank you, everyone.
On top of that, also remember we got the sponsorship channels open at the bottom. Echo 3D XYZ Taskade Science Times. Just check them out. And